I'd like your attention, please. Let's go ahead and start. We're going to be doing completing the square. My time. My time. Thank you. Completing the square. You learned it in Algebra 2. You did not like it. I believe most of you despised it. You didn't see a point to it. It was really, really hard, and you wanted to do quadratic formula the entire time. Okay? Completing the square is not easy, but it doesn't have to be difficult either. I want to make sure everybody has their graphing calculators with them today because there's going to be some numerical calculations that you have to do. And I don't want you to bust a brain cell doing the numerical calculations and get confused over that because I want you to know the process behind it. We all understand that. So you're just going to punch in the numbers today on your calculator so you don't have to think numerically. Open the door and please let him in. Okay, completing the square is used for the following things: finding the vertex of parabola, factoring completely, and finding the x-intercepts. Okay? When can you use this method? When it is degree 2, when your highest exponent is 2. What are the type of possible solutions that you can obtain when utilizing this if you're trying to find your x-intercepts? There can be rational, irrational, imaginary, or complex. If I'm a rational number, you know what that means? 1/2, -3/2, -4, +16. Those are all examples of rational numbers. Irrational numbers are going to be pi, square root of 17, square root of 3. How about 5 square roots of 4? No, I lied. 5 square roots of 3. Those are all examples of your rational roots. Imaginary is going to be 3i, -4i. Those are imaginary. Complex are going to be 2 plus 3i. Those would be an example of complex. Okay? We are not going to be dealing with these ones today. We're going to be dealing with rational and irrational. All right? Leading coefficient is the number in front of the x squared term. Now, steps. How do I do this? Replace f of x or y with the number 0. Replace f of x or y with the number 0. So any place you see an f of x or y, go ahead and make it 0. Then take your constant term over to the other side. What is a constant term? Nope. Nope. The constant term is the number without the variable. Number without variable. Leading coefficient must be 1. If your leading coefficient must be 1, you have to make it turn into 1, but you can't divide by it. Because if you divide by it, you lose your stretch or compress. So what you're going to do is you're going to factor it out. When you factor, you are doing division, but you keep it. Do we all understand that? It's hanging out there on the outside. It is the opposite of the distributive property. Do we all understand that? So if you distribute it back in, you get the original problem, and I'll show you how to do that here in a moment. Take the coefficient of the x term and divide it by 2, and this is known as a sidebar. You are going to hear me talk about sidebar over and over and over again. Are we remembering this from Algebra 2? Square this number and add it to both sides. Be sure you have multiplied by the number that you factored out, and then write the resulting number as a 1 binomial squared. So let's talk about a few other things. Quadratic function. There are 2 forms that you are able to actually use a quadratic. The first form is ax squared plus bx plus c, and then the other form is our standard form, a parentheses x minus h quantity squared plus k. I'm going to be real honest. Number 2 is so much more useful than number 1. Up, down, left, right, stretch, compress, reflect. It also pulls out your vertex. Your vertex is going to be HK. It is your left and right and up and down behaviors. Do we all understand that? Not only does that give us that, it also tells us the highest or the maximum or minimum value, okay, of the parabola. So that's why the standard form is so much more helpful. So here we go. What does this equation mean to you? So whenever you see this, what does the 2 mean? Stretch 2, left 3, down 7, which means my vertex would be what? What does that mean numerically? Left means -3, down means -7. Do we all understand that? Number 2, what does this mean to you? Reflect over the x-axis because it's on the outside. What's the 4? Stretch a 4, right 2, up 5. Now, what is your vertex? 2, 5. Do we all understand that, yes or no? Now, that gives us a lot of information, so we need every one of these to look like that. So how do we go about that? Well, here's what we're going to have. Rewrite the following as a squared binomial. How do I write this as a squared binomial? Well, how would I factor this into 2 binomials? How do I break down x squared? How do I break down 16 to get 8? To give me minus, and that means I have x minus 4 quantity squared. Now watch. If I had taken my middle term, which was 8, and simply divided it by 2, that would have given me 4, and that's exactly what I needed to put right there, isn't it? Do we see that? It just so happens the square root of 16 is also 4, because that is going to make it a perfect squared binomial. So if we look at number 2, this is going to be x. I need this sign, which is plus, and what's 24 divided by 2? Squared. Do we understand that? Isn't that awesome? What about this one right here? I need an x, bring down the sign, which is minus. What's 18 divided by 2? 9 squared. It's something you already knew, but you never really recognized before. Does that make sense? Super duper easy. Now, with that being said, let's go ahead and do what we're actually doing today. Because everything I just talked about has all been Algebra 2 material. Yes? Okay, so are we ready? I need you to stay with me on this because you're not going to like this today. Okay, find the vertex. Vertex. If I ask for vertex, what form am I looking for?
Standard form.
Standard form. I'm looking for this. Do we understand that? So I'm looking for standard form in the translations up, down, left, right, stretch, compress, reflect of the parabola by completing the square. So step 1, what does it say to do? Replace f of x and y with what number? 0. So this is going to be 0 is equal to x squared minus 8x minus 1. Step 2. Take your constant term over the other side. You know what your constant term is? It is a minus 1. So what am I going to do? Add 1 to both sides. So 1 is equal to x squared minus 8x. Step 3. You want your leading coefficient to be 1. What is my leading coefficient?
1.
That's the number attached to the x squared. Is that a 1x squared? Yes, it is, so I know I'm okay. What's the next thing I need to do? I need to do my sidebar. So if I come over here and I do a sidebar, what is a sidebar essentially? It's where you're doing some mental calculations. However, whenever I say sidebar, they're not just mental. I want you to write them down because if you don't, you're going to jack with your brain a little bit. So make sure you write this stuff down. Whatever makes you happy. Okay? So we're going to take our b value and divide it by 2. What is b in this problem? We don't need to worry about the sign. We just want the 8. So 8 divided by 2 is 4. And what does it say I need to do with that 4? I did b divided by 2. What's it say I need to do? After I take b and divide it by 2, I then need to do what? What's the next step? Square it. So if I square this, that gives me 16. And what am I going to do with that value? Add it to both sides. So I'm going to take 16 and add it to both sides. If I drop 16 units on one side of the scale, to balance the scale, I have to drop 16 units on the other side. Do we all understand that? Yes? Okay, next. 16 plus 1 gives me Now, you remember what we just did on this slide right here where you said I blew your mind? We have to take this trinomial that I have right here, and we need to write that as a binomial squared. So that's going to be x, bring down the minus, 8 divided by 2 is 4, quantity squared. Do we see that? Now, what is my goal? To get to standard form. So I'm almost there. So what do I need to do? I need to take that 17 over to the other side by subtracting it. So there's your standard form. Now I want your translations. Up, down, left, right, stretch, compress, reflect. So what's happening to this function? It is going to the right 4, down 17 to give me a vertex of what? 4, negative 17. 4, negative 17. The second one right here, you mean? Or over here?
For the vertex.
Okay, it's the second one is negative because I went down. Down means negative and left means negative. So that's why we use the line. Do we understand that? Okay, so that's an easy problem. That was the easy part. Okay? So we're going to take that same concept now, and I want to find the x-intercept. Well, what does it mean to have an x-intercept? The point on the graph where it crosses the x-axis. So if it's crossing the x-axis, what can you tell me about y?
0.
Y is 0. Where is y in this function? F of x is the same thing as y, and I want to put that as 0. Because whenever I have an x-intercept, that means my y value is 0. So in this place, in this equation, I want to solve this thing for y. So what do? Add 17 over. Now what? Take the square root, because the opposite of a power is a root. Do we all understand that? But when you take the root of a number and I have a power of squared, what do you have to do on the left-hand side with the square root of 17? What do you have to put in front of it? Plus. Yes. You have to put plus or minus there. Okay? And the reason why is because I'm canceling out a power of 2, and a quadratic means it's degree 2, which means I should have 2 x-intercepts. Do we understand that? So I have plus or minus the square root of 17 is equal to x minus 4. Now what? Add 4. 4 plus or minus the square root of 17 is equal to x. That is your x-intercept, but by definition of an x-intercept, it is an ordered pair. So I have 4 plus the square root of 17, comma 0, and I have 4 minus the square root of 17, comma 0. Do we understand that? The 4 is attached to the square root of 17. 4 is a rational number attached to a square root, which is an irrational number. So whenever you add them together, the whole total is irrational. So that's why you have to put the 4 there. We always put the 4 in front, so you don't mistake it to be put underneath the radical. You with me? For today, I want you to write it down 2 times. And the reason why is because I need you to understand that you're looking for 2 of them, which is why you got to have that plus or minus concept there. You with me? And once I know that you guys understand that you're looking for 2 of them and you're not dropping that plus or minus, I'll let you later on write it as 1. Okay? But for today, I want you to write it as 2 separate. Okay? Any questions on that? Okay, so that's kind of what your homework is tonight. But it's going to be with problems that you're probably not going to like. I did a nice, easy one for you. Now let's get a little bit more difficult. I mean, it might reappear someplace later on. Rance, do you know where that would reappear at? I mean, it could reappear someplace sooner than the test. Okay. Find the vertex of the function. How do I do this? F of x changes to 0. What was that? Move that 7 over by subtracting. Why? Guys, you have to have the leading coefficient be a 1x squared. Right now, it's currently a 2x squared. But what we know about this 2 is that it's actually the stretch of 2 of this entire polynomial. Do we all understand that? Yes? So I have to keep that stretch by simply factoring it out. When you factor out something, the operation that you're doing is division. So 2x squared divided by 2 is x squared. 8x divided by 2 is 4x. Do we all understand that? Yes or no? What's the next step? Sidebar. So we're going to come over here to our sidebar and we're going to do some calculations. We're going to take our b value and divide it by 2. What is b? Divided by 2 gives me. And what am I going to do with that? I'm going to square that, and that's going to give me a 4. And where am I going to drop that 4 at? Well, I'm going to drop it inside the parentheses. And the reason why I'm dropping it inside the parentheses is because my b value is inside the parentheses. So I'm going to add to that a plus 4 inside. So if I added a plus 4 on the inside of the parentheses, what am I actually adding on the left side? 2 times 4. Do we all understand that? Because that 2 is attached to the parenthesis by multiplication. Do we understand that? Okay, that 2 is on the outside of that parenthesis by multiplication, and I drop that 4 on the inside of that lovely little parenthesis, so it's actually going to be taking you 4 times 2. Do we all get that? So this is where I told you to go ahead and get out your calculator and to do that calculation right here. So we know this to be 8, and 8 take away 7 is 1. Do we all understand that? Okay, I drop down the 2, and then these 3 terms need to go into a binomial squared. So remember that? We took this x, we dropped down the sign, 4 divided by 2 is going to be 2's quantity squared. Yes? Do we get that? Yes? Okay, now what's my goal? Standard form. So we're going to subtract the 1. So 0 is equal to 2 parentheses x plus 2 quantity squared minus 1. There's standard form. Now talk to me about it. What's happening to this thing? Stretch of 2, left 2, down 1, to give me a vertex of what? -2, -1. Do we understand that, yes or no? Where am I going? Left 2, left means negative, down 1 means negative. Remember, up and right are positive, down and left are negative. We good? Okay, now what do you think we're going to do with that information? We found the vertex form. Now, what do you think I want next? Probably the x-intercept. This is where things get a little bit nasty. So we know we want it to equal 0, right? Okay, so we want that to equal 0. Now I need to solve this thing for x. So how do I do that? Add 1 to both sides. Then what? Oh, this is where things get a little nasty. You got to take the square root of both sides. And that means you take the square root of the top and the bottom. So this cancels out. You're left with x plus 2 is equal to plus or minus. What's the square root of 1? What's the square root of 2? Can't do it. Now, go down to the next slide. How do you rationalize the denominator? What do I do with that? You learned this in Algebra 2. In order to get a number outside of the square root, you have to have how many underneath the square root? If it's the square root, I have to have 2. If it's the cube root, I have to have 3. If it's the 10th root, I have to have 10 of them to pull 1 on the outside. You with me? Now, what we're going to do is we're going to multiply this by a value of 1. Multiplying by a value of 1 does not change a quantity. It just simply changes what it looks like. So I'm going to keep this, but I need to multiply by what I need to get rid of that square root. So the square root of 2 times what will give me the square root of 4? Yes. What you do to the bottom, you do to the top. This is what we call rationalizing. So this is going to be the square root of 2 over the square root of 4, which just happens to be 2. You know why? Because if you don't want to write it like that, write it like this. Do you see how the power and the root cancel out then? And it gives you just the 2. Do we understand that? So it just really depends on how your brain thinks of it. If you see the square root of 2 times the square root of 2 and you see that's the square root of 4, then do that. But if you see the square root of 2 times the square root of 2 is the square root of 2 quantity squared, it is exactly the same concept. So what I need your brain to understand in this problem is that you have to rationalize this. So when you rationalize this, you're getting plus or minus the square root of 2 over 2. Now, I need to solve this thing for x. So what do? Add 2, subtract 2. So x is equal to negative 2 plus or minus the square root of 2 over 2. Put this 2 over 1, and what should you have now? What do you need? What do I need? A common denominator. What is my common denominator here? My common denominator is going to be 2. So what did I multiply 1 by to turn it into a 2? What should you do to the bottom? So 2 times negative 2 is negative 4, and this already had a denominator 2, so I'm simply going to marry them together. What formula gave you that type of an answer before? Quadratic formula. Quadratic formula gave you those types of answers. Do we understand that? Yes? Okay. Oh, this looks familiar. I don't know. This might come back for you. It might not. Who knows? Okay. What do the directions say? Complete the square to find the standard form. Translations and the x-intercept. So f of x is equal to negative 3x, no, negative 3 over 5, quantity x squared plus 6x minus 5. What is ugly about that problem? What did you say? There is a constant, but it's on the inside of the parentheses. So I have this negative 3/5 attached to the parentheses by multiplication. Stable. Up and in. Okay, so what do? I'm sorry? I would distribute it back in. So I'm going to replace f of x with 0, and I'm going to distribute the 3/5 squared. So what is negative 3 times 6 is negative 18x over 5 minus, that turns into a plus 3. The 5's cancel out. Do we all see that? Yes? We can distribute it back in because right now we got to get that constant out of that parenthesis. So once we get that constant out of that parenthesis, we have to take that constant term over to the other side. So let's take that constant term over to the other side, making that negative 3 is equal to negative 3/5 x squared minus 18 over 5x. Now what do? I have to get out that negative 3/5 again, because that negative 3/5 cannot be attached to that x squared. Do you understand that? Because it needs to be a coefficient of 1. So if I pull out negative 3/5, what remains is x squared minus plus, sorry. Plus, do you see up here? That's exactly what you're going to have. Because that's what it was before. Do we see that, yes or no? Yes, ma'am. You can't because you have to multiply the 3 by the negative 3/5. Because it's on the inside. You can't pull out that 5. You can't pull this 5 out with first distributing to make it become a 3 and then put it over the other side. Essentially, you're distributing it to everything. Like you're doing a bunch of steps, but you're not showing it. Do you get what I'm saying? I get what you're saying. Mentally, you want to do it. I'd rather you not yet. Later on, I'll let you. Okay, so now, what do I need to do from here? Oh. Sidebar. Because I need to take my b value and do what? B divided by 2, so that's going to be 6 divided by 2, which is 3. And then what am I going to do with that 3? Square it, which is 9. So now I'm going to go ahead and add 9 where? Inside the parenthesis. So what I'm actually adding on both sides is what? Negative 3/5 times 9. Do we all understand that, yes or no? Six divided by 2 is 3, squared is 9. I'm going to add 9 on the inside of the parenthesis, which is attached to the negative 3/5 by multiplication, so I'm actually adding negative 3/5 times 9. Good? Yes. Why does it go on the inside? Because the b value that we chose to use, which was 6, is on the inside of the parentheses. So wherever your b value is, that's where you have to add that number at. Does that make sense? Okay, now, I want you to take your graphing calculator, and I want you to simply put this calculation into it, exactly the way you see it. What did you get? Everybody agree with them?
Yeah. Yes.
Negative 42 over 5 is equal to negative 3/5 parenthesis. What do these 3 terms turn into? Devin, you got that, don't you, girl? And now you don't have to think about it anymore, do you? Yeah. Should be. Unless there's a fraction. Sometimes if there's a nasty fraction.
Well, I do where we have to like solve them out.
It'll always be in your sidebar.
Our binder is only.
Yeah, it's always in your sidebar. It's right there. Always. Okay. All right, now, what are we trying to do here? Standard form. So what am I going to do? So 0 is equal to negative 3/5 parenthesis x plus 3 squared plus 42 over 5. There's your standard form. So what does that mean? What's happening to this function? Uh-oh. Careful. It's reflected over the x-axis. The 3/5 is compressed. The plus 3 is to the left 3, and the plus 42/5 is going to be up 42 over 5. So that means my vertex is going to be what, folks? Correct. Do we understand that? Okay, so now what do I want yet? Oh, we're not done yet. What do we want yet? We want the x-intercept. So how do I find the x-intercept? If I'm going to go back up to here, and I'm going to utilize this right here. You see that? So that's going to be negative 42/5 is equal to negative 3/5 parenthesis x plus 3 squared. So to find my x-intercepts, how do I solve for x? What do? Divide by negative 3/5. When you divide by negative 3/5, that's the same thing as multiplying by its reciprocal, right? double negative creates a positive. The 5's cancel out. And what's 42 divided by 3? 14 is equal to, those go away, x plus 3 squared. Now what? Square root of both sides. And what did I miss? Plus or minus. So plus or minus the square root of 14 is equal to x plus 3. Subtract the 3. So I have negative 3 plus or minus the square root of 14 is equal to x. So how do I want you to write your x-intercepts? Negative 3 plus the square root of 14, comma 0. Negative 3 minus the square root of 14, comma 0. Yes? That's how you do tonight's homework. Can you do it?
Yes.
Okay, we have 2 other things that I want to try to get through in the next 5 minutes. Okay? 2 other problems that we're going to get through in the next 5 minutes, and these are straight out of the homework as well. So number 19, the vertex is negative 2, 5, and the point is 0, 17. This is not exactly number 19, but it's darn close to it. I changed the problem. Okay? Now, what you're going to do is you're simply going to write down your standard formula. And whenever I say vertex, that's HK. Whenever I say point, that's what? XY. Do we understand that? So simply plug and chug into the formula. So y is 17, a I don't know, x is 0, minus the negative 2 squared, and k is 5. Minus the negative. So this is 17 is equal to a parenthesis 2 squared plus 5. What's 2 squared? 17 equals 4a plus 5. 12 is equal to 4a. 3 is equal to a. So what is my equation? Y equals 3 parentheses x plus 2 squared plus 5. There's the equation that goes through the ordered pair 0, 17 with a vertex negative 2, 5. You had to find A, which is your stretch or compress, to be able to do that. Do we all understand that? Yes, sir. Yes. Yep. Okay, last thing. Find the x-intercepts of the following equation by using the graphing utility and the 0 functions. So you literally are going to pull up your graphing calculator, and you are going to go to a new graph. So go to a new graph and type that in. Is it solved for y already? Is this solved for y already? Yes, Mrs. Yoder, it's solved for y. Good job, class. So once you get a new document up and you want a graphs page, and you've typed that in, that is going to be 2x squared minus 7x minus 30. And I'm going to hit enter. All I want are your x-intercepts. So that means you're going to come over here to menu. And you want analyze graph, 0. Go to the left, hit enter. Go to the right, hit enter, and it gives me 6, 0. Do it again. Menu, analyze graph, 0. Go to the right of the 0, hit enter. Go to the left of the 0, hit enter. Negative 2.5, comma 0. Do we all understand that? Yes. Yes. Once you find the 1, 0, you have to go back into menu. Tonight's homework is going to be worksheet 2-1. Now listen up. Problems 1 through 8 is matching. They are already in standard form. So all you have to do is up, down, left, right, stretch, compress, reflect to figure out which graph goes with which equation. Yes? Pass it down, Ethan. Problem 9 through 16 is where you're going to write the equation in standard form, identify the vertex, find the x-intercepts, and then check it graphically. That was my new calculator. 17 and 18 is the vertex and the point, and then 19 and 20 is graphically. Any questions on tonight's homework? Okay, have a great day.